So, let us start with ultimate bearing capacity and the shallow foundations. I can write it shallow foundations, then your bearing capacity. This is B, this part is your L and this is your dF, depth of the foundations. As per the Terzaghi, if dF by B is less than equal to 1, depth of the foundation by your width of the foundation is less than 1, then you can say it is shallow foundations. Later some researchers, after the research, it has been categorically changed, dF by B less than equal to 2 to 3 is called your shallow foundations. If I divide into shallow foundation and deep foundations, what is the criteria? If the dF by depth of your foundation by your width of your footing is less than equal to 2 to 3, then we can categorize as shallow foundations, and if it is not, then it will be deep foundations. Now, types of failures in soil. At ultimate load, types of failures in soil at ultimate load. If I can put it into 3 categories, one is your A, general shear failure, B, local shear failure, and C is your punching shear failure. So, what is your general shear failure, local shear failure and punching shear failure? I have to draw just from the general shear failure a bigger one. I am talking about general shear failure. Depth of your foundations. So, particularly general shear failure, foundation supported on particularly on a means foundation supported by a dense sand, or stiff clay. In that case, it is expected you are supposed to get general shear failure, and in general shear failure, if I draw load versus or load intensity Q versus your settlement, definitely we will get a peak. Distinguished failure mode we are supposed to get it in case of your general shear failure. So, now come to your local shear. In local shear failure, so generally if foundation is supported by medium dense or clay soil, in that case we can expect local shear failure. So, in that case peak load is never observed. So, if I draw load versus or load intensity Q versus settlement, I am supposed to get kind of this type of your load versus settlement. Now, come to your punching shear failure. In punching shear failure, let me draw it. This is your footing, this is your Q, and this is your depth of the foundations, and this kind of load settlement, load per unit area or pressure intensity Q, load per unit area is your settlement. You are supposed to get it. In what kind of foundation soil you are expecting a punching shear failure, particularly in case of loose sand or soft clay. Then it has been, in case of punching shear failure, as its name is punching, it will go inside, the foundation will go inside your, particularly inside this your soil bed. So, another classification has been given, local shear failure as well as general shear failure. So, that has been given by basic, he has given a certain criteria, I will explain it. So, particularly for as for basics criteria, it is general, and second one is your local shear failure. So, particularly for general shear failure and local shear failure, if I put it here general and local, how do I distinguish? For sandy soil, for sandy soils, if phi value is greater than equal to 36 degree, generally it is general shear failure. Phi is less than equal to 28 degree, that is your local shear failure. So, intermediate value will be extrapolated. Now, it is general and local. In between, what is the conditions? If you look at phi is greater than equal to 36 degree, it is general shear failure. Phi is less than equal to 28 degree, it is local shear failure. Another case is your, second case is your, if relative density is greater than 70%, in that case we say it is general shear failure. If relative density is less than 30%, it is called local shear failure. So, for C5 soil, it is particularly sandy soil. For C5 soil, in general shear failure, soil specimen or failure occurs at a small strain less than 5%. This is your general shear failure. Means for local shear failure it is 10% to 20%, then in that case it is local shear failure. Now, let me summarize. So, types of failures in soil at ultimate load, particularly it is required for your foundations. Category 1 is your general shear failure, second is your local shear failure, third one is your punching shear failure. In general shear failure, generally it occurred if your foundation soil is dense sand or a stiff clay. Look at the condition, if foundation soil is dense sand or stiff clay. In that case, you are supposed to get a failure, means particularly peak in a load versus settlement diagram, increases, peak and decreases, so that you can very easily find it out ultimate bearing capacity. Another part is, in that case generally heave is observed. This is your heave around the periphery of your foundations. These are all indication for your or conditions or criteria for your general shear failure. Now come to local shear failure. Generally it happened if foundation soil is constructed over medium dense sand or clay soils, and you are supposed to get, if you load versus settlement, peak is never going to happen. It increases, settlement increases with increase in load. In punching shear failure, generally it happens if your foundation soil is in loose sand or soft clay. In that case it punch, it goes inside. So, entire foundation goes inside. This is your load versus settlement diagrams. Now come to basics criteria. Basic has given a criteria, general shear failure and local shear failure. For particularly sandy soils, if phi, angle of internal frictions, phi is greater than 36 degree, greater than equal to 36 degree, that is called your general shear failure. If phi is less than equal to 28 degree, this is called your local shear failure. In between what will happen? Suppose phi is equal to 30 degree. So, basically you have to extrapolate. Once after that our bearing capacity part will be, I will cover bearing capacity. So, if phi value is 30 degree, in between general and local shear failure, it has been termed as neither general nor local, rather it is a mixed shear failure. So, bearing capacity will be extrapolated or interpolated between phi greater than equal to 36 degree and phi less than equal to 28 degree. Another case, if relative density is greater than 70%, in that case it is general shear failure. If relative density is less than 30%, it is local shear failure. For C5 soil, generally failure occurs at a small strain less than 5%. How do you know that? Suppose you are doing a C5 soil triaxial test, stress versus strain, stress versus strain, stress versus strain. In that case, you are getting a peak, and that to be termed as a failure, and the strain should be supposed to be less than 5%. In that case also you can say general shear failure has happened. If strain at failure, particularly soil, varying from 10 to 20%, this case is called local shear failure. Now let us start with your bearing capacity of shallow foundation. So there are different terminologies. Before you go for Terzaghi's bearing capacity theory. It is your net load intensity. Net load intensity is equal to gross pressure minus your overburden pressure. Overburden pressure, that means gamma dF, overburden pressure at the base of footing. Most importantly, now the terminology what I am saying, this will very often I am going to utter it many times while designing these foundations. Ultimate bearing capacity, net ultimate bearing capacity, net shape bearing capacity, gross shape bearing capacity. So, this should be in your mind. Once I am saying what is ultimate bearing capacity, you can very easily catch it. So, now next first part is your ultimate bearing capacity. Ultimate bearing capacity is your maximum gross intensity of load. Definition is maximum gross intensity of load that the soil can support before it fails in shear. Generally, notation is QU. If I say ultimate bearing capacity of the foundations of the footing, what does it mean? Look at here, maximum gross intensity of load that the soil can support before it fails in shear. Before it fails in shear, by means of shear only. This is your ultimate bearing capacity. The terminology is your Q subscript U. So, B is your net ultimate bearing capacity. Net ultimate bearing capacity QNU is equal to QU minus gamma dF. So, here it is a maximum gross intensity, you can write it maximum net intensity of load that the soil can support before it fails in shear. That means QU ultimate bearing capacity minus gamma dF. Gamma dF is your gamma overburden pressure, gamma dF up to your foundation level. Now, net shape bearing capacity, Generally net safe bearing capacity we write it QNS. Q for is your ultimate, N for your net, S for your safe. These are all universal notations. You cannot write it CNS or capital QNS, you cannot write it small QNS. So, net safe bearing capacity is, if I write it QNS, which is equal to QNQ divided by your factor of safety 2.523. QNQ is your what? QNU, sorry. QNU is your what? Net ultimate bearing capacity with a factor of safety divided by your factor of safety. This factor of safety for your shear, and it is generally taken as 2.5 to 3 for foundations. So, net safe bearing capacity is your net ultimate bearing capacity divided by your factor of safety, and factor of safety is varying 2.5 to 3. Now, gross safe bearing capacity, I can write it, if it is net safe bearing capacity, you can write it gross safe bearing capacity. So, gross safe bearing capacity, net safe bearing capacity plus gamma df, this is your overburden, which is equal to net ultimate bearing capacity divided by your factor of safety plus gamma df. This is your gross safe bearing capacity. Next, net safe settlement pressure. Net safe settlement pressure, which is equal to QNP. Small q, N for your net subscript, then P is your pressure. So, net safe settlement pressure. So, what does it mean, net safe settlement pressure? Maximum net intensity of loading that can be allowed on the soil without exceeding the permissible or allowable settlement. Generally, for individual footings, the permissible settlement is varying between 25 mm to 40 mm as per Bureau of Indian Standard. Look at here, net safe settlement pressure, net safe settlement pressure. The terminology is coming net safe settlement pressure, maximum net intensity of loading. It is the maximum net intensity of loading that can be allowed on the soil without exceeding the permissible or allowable settlement. If I draw load versus settlement, or maybe pressure intensity versus your settlement, generally settlement in mm. So, what is your allowable settlement? Look at here, if this is my load versus settlement curves, what is the permissible or allowable settlement? Let us say 25 mm, this is your 25 mm, you draw it. Corresponding to that load, you can say that that is the maximum load intensity that is allowed on the soil considering your allowable settlement of your 25 mm. that is why it is called net safe settlement pressure. Then another one is your net allowable bearing pressure. QNP, net safe bearing pressure, net allowable bearing pressure. So, we can write it Qn allowable, N for your net allowable. So, it is your particularly if you look at here maximum net intensity of loading maximum net intensity of loading that can be imposed in soil with no possibility of shear failure or excess settlement. So, if I write it, so bearing pressure in that case bearing pressure 1 net safe bearing capacity second net safe settlement pressure. So, out of this comparing both these smallest one is considered as net allowable bearing pressure. So, net allowable bearing pressure, what does it mean? I wrote it, intentionally I wrote it, I could have said, so you can note it down. So, maximum net intensity of loading that can be imposed in soil with no possibility of, you can say that with no shear failure, that means shear failure means what does it mean? No bearing capacity failure, that means net ultimate bearing capacity failure, net safe bearing capacity. So, no net safe bearing capacity or no excess settlement, that means net safe settlement pressure. Find it out net safe bearing capacity considering shear failure, find it out net safe settlement pressure considering permissible settlement. Out of these two, which is minimum or which is the smallest, that one you have to consider for your net allowable bearing pressure. The symbol is Qn allowable. So, these are all what we have covered today. We have covered today shallow foundations criteria, dF by B less than 1, generally this is your Terjagi has given. Later on the research has changed. So, dF by B between 2 to 3, that has been called shallow foundation. More than that, it is your deep foundations. Then what are the different types of failures in soil at ultimate load? General shear failure, local shear failure as well as punching shear failure. Then basic has given some criteria, basic criteria, this is called general shear failure as well as local shear failure based on your phi value, angle of internal friction of soil, based on your failure criteria, means strain rate, small strain or large strains. Then terminology, definitions, bearing capacity of shallow foundations, net load intensity, ultimate bearing capacity, it is QU, net ultimate bearing capacity QNU, then net shape bearing capacity with a factor of safety 2.5 to 3, gross shape bearing capacity, then net shape settlement pressure QNP, then net allowable bearing pressure Q net allowable. I will stop it here. So, next class I will start it Terjaghi's bearing capacity theory. This is a basic theory Terjaghi has given for your bearing capacity calculations, and now this once the bearing capacity is over, then you will go for settlement, what are the different settlement analysis. Then once it is over, then we will go for foundation designs, shallow foundations, then we will go for deep and other chapters. Thank you.